Before we go ahead and play with the clustering and breaking those elements, I want to play a little bit with the surface for the source. The thing is, the surface is very flat, and I don't like a flat surface because sometimes they create not very good results, especially when you create a flame. So what I want to do, I want to add the mountain sub to add some noise on this surface. So we can increase the grid resolution, but where we apply the attribute paint, it will link to the point number. So now if I apply my grid and make, like, I don't know, the bigger res, like multiply by 3, you will see that it's break our attribute paint and remove the different points. So what I want to do, accept this resolution, okay, I will leave it as it is, but before we go into the mountain sub, I will use the subdivide node to add a little bit more polygons here. When we use the subdivide node and create additional primitives and points, they will match attributes, and we're gonna have the same, areas, but they are a little bit more in details. So with the mountain sub, I guess I will increase the height a little bit more, like 2 meters in this case, and add the time expression to animate this mountain. Okay. Maybe visually it's not the best picture we want to have, but anyway, we create the attribute noise, create a scatter. So now this scatter is looking like here. There's some problems over there. We have less points than I want to, but anyway, we can play with those points. So now let's try to separate those elements, break into some different parts. So I know a few systems can allow us to break one simulation into different parts. And the first system which I can remember, and the most simpler choice, is the cluster system. Using the clusters, we can break our source into some parts and simulate those parts separately. Now, how we can, using the clustering system, we can basically create clusters to, avoid some empty spaces. But when we create the clusters and put them into the pyro simulation, our clusters will calculate all at once. But what I want to do, I want to separate this source to clusters and simulate each cluster after another one. So not all together, one by one. So how we can do this? We have a nice top network in Houdini 18, and we can use this top network to add a wedge node, which will control which cluster we're gonna simulate now. So let's break this thing into parts. What we can do, I can add a curve along my source. Well, we can create the automatic process, like create bound around these points, but anyway, maybe it's a little bit faster just to draw some curve. Actually, I want to draw a line. We can see that the first point here near the 50 and minus 50. So the first point will be 50, 0, 0. Oops, sorry, wrong. 0. And another point should be minus 50, 0, 0. Come on. It's a little bit dark here. So let's remove this guy. So we have a line, a straight line, the first point, another point. Now what I want to do, I want to transform this line and write this line above the surface. So put it here, like translate 10, come on, 10. All right, so I put here why I'm doing it. If you go to the blast, we can see that this line is here. Let me just template this. And I want to make some points on this line. And when I create lines on the 0 position, it will create it on the middle of our grid. But when I draw the mask attribute, mainly our points was created here closer to the Z side, the axis. So I drag my line closer to here. And then what I want to do, I want to use a resample node to add some points on this line. By default, we have the segment length. It means that we create a bunch of points which has a distance between those points, 0.1. But I don't want to use a distance, I want to set the maximum segments. So using this option, we can set how many segments I want to create. In this case, I want to create 5 different segments. And it will create 1, 2, 3, 4, 5, 6 points. Okay, we can check this thing. 0, 1, 2, 3, 4, 5. Okay, 6 different points. And those points will be my cluster center. So let's add a node to remove a primitive, leave just points. So delete geometry, but keep the points. And we have all those points here. And now I want to set the clusters here. Go to attribute, tab, attribute wrangle. And let's create the integer attribute cluster and grab ptnum from my points. So now we're going to have a cluster attribute which have a number from 0 to 5. 5 different clusters in this case. So what I want to do now, after my, I guess, scatter node, let's drag it over here. Here, let's move it up. Oops, sorry. Come on, move up. I'm going to use the attribute transfer node. So I want to transfer my cluster number for each point inside of my source. So this is pretty simple. Go to points, select cluster, and with a condition, we can apply a distance to cover all my points. So we can increase this distance to like 20. To be sure that all my points have a cluster attribute, we can create some colors. So we can create the attribute WAP, and inside of it set the bind cluster attribute, cluster, it's integer, make a random number from this cluster and put it into the color for my points. So now, 3D, I guess, 3D output. So now you can see that all my points have a different color representation. So first cluster, but actually this cluster have index 0, 1, 2, 3, 4, and 5. All right, so that one task is done. We have 5 different point groups. Each of those points has a cluster number from 0 to 5. So now we need to use this cluster number to set, okay, I want to create a simulation. The first simulation, I'm going to use just points which have a cluster 0. The next simulation I want to create with points which have a cluster 1. That's interesting. We have some. Let me just create a blast node to see if cluster equal 1 points. Yeah, we have some points from cluster 0 from here. That's interesting. Maybe I'll increase the radius. Yeah, that's bad. Okay, so to avoid some unexpected result, yeah, those 3 points will not be affected on our final result, I guess. But anyway, it's always better to correct and keep all points at one area. So now let's use this cluster number to make to separate our simulation into those cluster parts. For this, I'm going to create a top network. Top network. Let's call this top network fire top. Have a local sheller, and let's play with this a bit. And here we begin with the wage node. And the wage allows us to create the count for our simulations. So we have the wage count of 6. We have 6 clusters: 0, 1, 2, 3, 4, and 5. 6. Then I want to add the wage attribute. Let's call this attribute cluster number. It's pretty simple, cluster number. And it should be the integer attribute type because our cluster is integer. And the range from 0 to 5. Okay, so keep in mind that wage count 6 because 0 goes in count. 0, 1, 2, 3, 4, 5, 6. And now I need to add the ROP geometry output to save our simulation separately. It's very important because if you will save with the same output file name, we will rewrite each time the same file sequence. I don't want to do this, so I need to, first thing is using the frame range, and I want to make simulation, let's make it 240, I don't need 300 frames, so 240. And what I want to do, I need to use the thought path. So what is the thought path? We actually need to add here my fuel out. So with the fire source, I select my fuel out. That's going to be my thought path. So the first ROP geometry will create a source for our simulation. So let's call a source wage. I want to save my source. It's not necessary because, well, it's not very hard to create the rasterized attributes, but I want to create this source because I want to create the source separately for each cluster. Okay, not just choose all this area just per cluster. So I will save. Let's rename it. Let's call this source. Let me more room. Let's call this source. And then the wage, W. And then in those, I know how to call this. It's like quotes. I need to type the wage index. So wage index. So why I'm doing it? The thing is now, let me just remove this $OS. So just $f. This wage index will be different depending on the wage count we're going to use. So we have 6 different simulations, and each time, except of this word, we will paste V1, V0, V2, V3, so on and so forth. Okay, so if I press middle button, we can see this because it will not apply for now, but we will use this like a command to set what number we will apply for the for this sequence. Okay, so we can play with the ROP page and set that all frames in one batch. I want to use all frames in one batch. And this ROP geometry will create a source. Okay, so we will use a fuel out, not for all my area, but separately for each of those clusters. And we will cache this source out. So we will save this source as a volume. And then we're going to use this source, pre-cached source, for simulation. Okay, so the next thing I want to add is another one, ROP geometry output. And for this ROP geometry, what I want to apply, let's rename it the pyro wage. So this is wage for my source and this wage for my pyro. So what subpath I want to use here? Again, frame range 240 should be fine. So here we create a path where I'm gonna save my source. So now I need to use this path to grab this source and put into the pyro simulation. So here inside the file source, I want to add the file node, and that I want to put here my path from the source. So how can I do this? I can simply go to the file tab, copy this path, copy parameter, and here in the file, paste relative reference. So now I will use each time in each wage, I will use the proper source. Okay, I'll load the source here. Let's name it source in. And I'm going to use this source for the pyro simulation, not this, but this. So let's rename it and call this fuel out wage. Okay, so there's another null. And I'm going to use this. It doesn't work for now, because I'm going to use this element for getting a proper source inside of the flame source. So where you have fuel out wage. That's what we're going to use. It doesn't work for now because we don't create any kind of cache for now, but we will. So another thing is, let me just check this here. I want to back it a little bit, because another thing is very important is our center for the smoke objects path. The thing is, by default, we can see that our center of the empty smoke object is on a 0 position. But when we apply a source somewhere here, let's say from this 0 cluster, but when we create a source in this area, it will not find the source for simulation. When we create our sim inside of the dot network, we will not find the proper attributes here because they will position over there. So we need to change the center of our smoke object each time depending on the cluster number we're going to use. So basically we need to put this center in the center of each cluster. How we can do this? Well, actually it's not too fancy. We just need to separate our clusters somehow. Here we have our points, and this point numbers is like 0, 1, 2, 3, 4, 5. These are our clusters. So basically we can create the point, we can remove all points except of one point depending of the wage. So let's say if we start our wage simulation, it will grab point 0. It means that we will create this, bunch of points, we will create this volume source, and we will store this source inside of our file. And we grab this source and put inside of the fire sim. Okay, so we should see this source like here. Okay, so now we need to tell the system which what cluster we use for now. So I want to remove all other points except of our active cluster point for now. So for my first simulation, I want to remove all those points 1, 2, 3, 4, 5. In the next page simulation, when it's take point 1, I want to remove point 0, 2, 3, 4, 5. So I want to select just my active point. To do this, I want to add another attribute wrangle. I want to say that let's create some cluster number attribute. Cluster number. You remember we create a cluster number attribute over here on a page cluster number. Let me copy that. So cluster number. Okay, here we go. And let's apply a cluster number 0 for all my points. So now they have a cluster number 0. Then let's say if my cluster number will be equal to 1, let's say 1. I want to remove point from 0 by ptnum. Oops. So what we have now is, I'm sorry, not equal 1. Sorry, why 1? And now just my mistake 0. Oh, come on. If cluster will be not the same, okay, as 0, then remove this point. Okay, so if cluster number will be 0 and our cluster attribute will not be a 0, then we remove a point. So if it will be equal 0, the point will left. So we still have a point 0. All right. So if you cluster 1, we will have point 1. Cluster 2, we're gonna have point 2, 3, 4, 5, and etc. You just have the same number 0 because the point number change always. We left just 1 point, so it's always will have a point number 0. So we can simply add, except of this 0, I want to add a channel, and let's call this channel cluster number. Cluster number. Make this cluster number over here. And what I want to do, I want to add here attribute cluster. Actually, you can paste it, cluster number. So now how it works. When we start the wage simulation, here on this cluster number attribute, we're going to put a 0. We compare, is our point have the same number as the cluster number? Yes, then we leave this point. If it has a different number, we remove this point. So each time we're gonna leave just that point, we have a proper number. We done with simulation, then our wage system starting another simulation with the cluster number 1. And then it pays here 1. So each time when we have a wage simulation, we're gonna left just point with the number of the simulation. Okay, so let's add a null object and call this C cluster position. So each time we're gonna move point 0, 1, 2, 3, 4, we're gonna leave point from the number of our wage simulation. So the same attribute wrangle, I want to copy, I guess, somewhere after the attribute wop. So I don't want to use this blast node. I will use this attribute wrangle. So each time depending on the page number, we're gonna have a different source depending on the cluster number 0, 1, 2, 3, 4, 5. So we link this attribute to the page number. All right, so that's one thing I want to add here. Another one, go here to the file tab. We need to continue with this stuff. So now I want to add the path, so path from our source. And this path should be the out of from our Pyro simulation. So here on the file cache, we have the DOP import field, which is grab information from our Pyro simulation and put this information into the file cache. But I don't want to use this file cache. I want to put this information into the page geometry. So I create a null object, put it here, and call this, let's say, Pyro out. Cool. I want to make sure that I have a proper channels, the density, velocity, temperature, flame. Yeah, that's what I want to add here. I even can remove velocity if you don't want to use this. So now let's back to our top network, and I want to grab my sub path here from the file cache, the Pyro out. So again, this page create, this page create the page count for us. Then we create a source per each cluster. And then we create a simulation using this source and put inside of the file cache Pyro out. All right, and we're gonna save that, let's say a name. I can copy this actually and paste it here and make call this, I don't know, maybe like a file $w wage index and $f BGUSD. That's what I want to, and all frame in one batch. Cool. And we can even add some partition by attribute. Partition by attribute. And add the attribute wage index. Wage index. I just want to make sure they're properly write this thing, and I think that distinct attribute values. All right. Let me see what we have. That thing is right, the file cache. So we can simply, remove this, or can keep it just for the moment. Okay, so this is my ship. Again, the file source. Just want to make sure this all works. Okay, let's just try to start this sim. What I want to do for the first start, I want to increase my voxel size to like 0.2. I just want to see does it work or not, and then we will delete all information and begin simulation with the lower voxel size. So to make this thing works, we need to press this cook the output nodes work it items. Yeah, it's want to save all other stuff. So yeah, I save my scene and the page is done. So now I can see that it's waiting 2882 and it's beginning to work. So let's go to our file source, I guess, and let's see, do we have any files there? And yes, we have. Yes, we have. Okay, the source W5, source W4. So now we can see that we create a source for cluster 5 and cluster 4. It works. You can refresh it. Refresh. It works. It definitely works, but I want to wait till our simulation begin to work. So this is the sourcing. We create a source page and then our partition. So all 6 pages. Visually it's very beautiful. I just can sit here and look on this stuff, how it works. So the first page create a source, and it's very important because without a source we can create a file simulation. And it's working pretty fast because, as you can see, we create 2 simulation per one. So source 54, 200, 235, and 237, 240. So we're done with the sourcing, and now we create a file sim. And I get that file W5 will be wrong, and a reason for that is there's not too many points. So this is our source, and I guess that it's not the best cluster for simulation. Okay, anyway, we can avoid this cluster. We still have 5 clusters left. So you can see that it's just 3 kilobytes. It doesn't work. And somehow oh yeah, cancel that. Let me stop this stuff because there is something I forget to set. So stop task and delete all result from a disk. Okay. So why it doesn't work? In fact, I forget to reposition my container each time into the center of each cluster. Okay, so let me choose cluster 0. It's over there. And I want to use this null object, cPosition, to define what cluster or actually where is the point or the center of cluster for now. So each time when I create a simulation using the wage, each time this point will represent the center of the cluster. Each wage simulation put here number from 0 to 5, and we will have a different point position depending on the wage. So I'm going to use this point position to add a center for my container. So let's add a centroid. Come on. Let's add a centroid. And I'm going to use our source file source node cPosition. And I want to grab the X center. Copy that, enter. Control V, change to Z, and here I changed to Y. So now each time, depending of the wage number, it will put center of the smoke object into the center of the cluster. And that will work. So okay, let's start this stuff again. Okay, save changes. And I'll wait a bit to see a result. I don't want to take your time, so I make a pause. And now that works. We have the fire wage 5 and fire wage 1 created. So wage 1 is 777 frames head. So let's go to fire cache and let's disconnect this guy. Let's load the fire version 1 fire source, and here you go. There is our fire. Cool. There is our fire. So this is our fire 1. Let's call this fire 1. And I'm going to create fire 2, or actually not, fire 0, I guess. Fire 1, because we're starting with 0. Fire 2, fire 3, and fire 4. Fire 5, I don't know will I use it or not, because it's very small. As you see, there is very small area and not too many points. So maybe those will be enough. So here V1, V0, V2, V3, and V4. That's what we've got. Should have. Okay. So is fire, well, fire 5 I guess is not correct too. Fire 1 is work 100, frame 100. Yeah, how awesome. So let's stop this. Let's connect the fire post process, or we can remove it. All right, so now let's stop this fire top. I don't want to spend the time for tests. We can see that it works. So our next task is change the smoke object voxel size to 0.1, and that's actually it. I get that I will leave. The wind is fine. Let me just last time look at here. 5.5. We can reduce the cooling rate a little bit to 4. Let's say, and let's add 3 sub steps for a max simulation. Max sub steps, yeah. Okay. So I'll go to fire top, remove delete result from disk. Oh yeah, and I forget to link my voxel size to volume rasterize. So I copy this parameter, and here paste relative reference. It's still 0.1, but I just want to make sure that it's the same as in simulation. So again, get back here, select my Pyro YH, Ctrl S, and start this simulation.